Now we're going to talk about linear relations and functions. A linear relation is a relation that has a straight line for a graph. It could be diagonal, it could be vertical, it could be horizontal, but it has to be a straight line. Some examples of graphs that are not linear are ones that have a bunch of curves in them, just one curve, they do this sort of S shape, might be an upside down curve. Anything that's not a straight line would mean it's not linear. If you're looking at the equations, these are all examples of linear functions. They have two variables. Those variables might have coefficients, but they are not in the denominator. The variables are not being multiplied together. The variables are not squared. The variables are not underneath any radicals. So, a little pop quiz. Which of the following are linear functions? We have f of x equals 8 minus 3 over 4x, g of x equals 2 over x, and h of xy equals 3xy minus 4. If you guessed A, you are correct. The problem with B is we have this variable in a denominator. That is not linear. The problem with C is we have these two variables that are being multiplied. Again, not linear. But in part A, we have a constant, we have this variable with a coefficient. None of those rules are being broken. Let's look at a word problem. The growth rate of a sample of Bermuda grass is given by the function f of x equals 5.9x plus 3.25, where f of x is the total height in inches x days after an initial measurement. So x is the number of days since the measurement. How tall is the sample after 3 days? So we know we waited 3 days to take this sample. So that means that's our x value. Anywhere we see an x, we're going to put 3 for 3 days. So we've got 5.9 times 3 plus 3.25. Then using PEMDAS, first we're going to multiply. So 5.9 times 3 is 17.7. 17.7 plus 3.25. And then now we can add them together, and we get 20.95. And since we were in inches, that is the total height of the Bermuda grass after 3 days.